Okay, here we go. Let's take a look at what we have here. We have a hemisphere. Dun, da, da, da. What is a hemisphere? Well, actually, a hemisphere is if you look at a regular sphere, what you're going to do is you're going to cut it in half right along that nice little equatorial line, that nice little equator line. And eventually what you're going to get is something that looks like this. But what's really, really crucial here is to note that this, in fact, is a solid. Well, why is that important? One of the reasons why is because now you not only have half a sphere, you also have this solid surface up top in here. This is not a bowl. It's not like a lunch bowl or a cereal bowl that you eat your cereal out of. This is actually like cutting an orange in half. You have a surface here to worry about. And remember, that surface that you're worrying about there, since you're dealing with area, you're dealing with pi r squared. Aha! But what about this sphere? What about that thing? Well, let's look at this. Don't forget that we have a formula for sphere. The formula for the surface area of a sphere is 4 pi r squared. But wait, this is a hemisphere, which is half of a sphere. So guess what? You're going to multiply it by a half. This turns out to be, check this out, 1/2 of 4 pi r squared is actually 2 pi r squared. But here comes the important part. Here comes this surface here. That surface is another circle, which we just figured out is pi r squared. So we're going to add that to this. Now check out what happens with the formula. This is the coolest part. You have 2 pi r squareds plus another pi r squared. So in other words, 2 pi r squareds, which is this beautiful surface out here, and the pi r squared, which is this exposed surface here, ends up being 3 pi r squareds. Oh my goodness, that's amazing. That is so incredibly cool. Now, read the directions though. This says it has a diameter of 7 feet. Okay, this has a diameter of 7 feet, then remember, diameter means all the way across. We don't need all the way across because we're dealing with radiuses. So this, in fact, is only 3.5 feet. That's the radius. Aha! Well, let's put that in here. Let's see what we can do. Okay, 3 times pi times radius, which is 3.5, all squared will give the surface area of that hemisphere. Okay, this works out to be, I'll bring up the calculator here, 3 times pi times 3.5 squared, 3 times pi times 3.5 all squared, you're going to get a beautiful answer of 115.45. Now 115.45, and remember this was in feet, so this in fact is feet squared. Now check the answer though. The question may say to the nearest tenth. Aha! It does say round to the nearest tenth. Okay, so our answer currently is not right. Let's go back to the calculator and make sure that this looks right. 4, 5, there it is, means you round here. So that pushes that over. Guess what? That is 115.5. So this works out to be 115.5 feet squared. That is your surface area. Now, I got a really important point here though. Very, very important point that you have to see. If that was a bowl, meaning that this is how I answer my phone. Hello. If it's hollow all the way down, right, that means this pi r squared is no longer significant. If this was a hollow bowl, the surface area would be this right here. Now that would be the outer surface area. The inner surface area, that's another big, huge task we'd have to look at, but not in this podcast. Maybe one a little later on. Okay, you got this? Now, let's go answer the next question. The next question says, aha, what is the volume of this hemisphere? Well, wait a second. Hold on a second. Let me clean this up. Ain't that pretty now? Okay, so let's figure out the volume. Remember the formula. The formula was 4/3 pi r cubed. Okay, remember, you're given a diameter. So make sure you're dealing with radius again. And in this case, you don't care if this thing is a solid hemisphere or it's one of those hollow bowl-like looking things. Of course you don't care. The reason why is because you're trying to find the volume. You're trying to find the whole thing. So the solid part doesn't have anything to do with this at all. So now, radius, 3.5 feet. Don't forget. Okay? Punch it into your calculator coming up right here. 4/3 pi and then r cubed. Watch out for that cube. It's cubed because don't forget, we are talking about volume. Okay, bring up the calculator. Here it comes. 4/3. Always in your calculator, put any kind of bracket in fractions. 4/3 pi r, which is again, oh, look back, 3.5 cubed. 3.5 hat cubed. There's your answer. Punch it. Now, don't forget, that's for a full sphere, right? That's for a full sphere. Our problem is we're dealing with half a sphere. So we got to take whatever this number is and multiply it by a half. Or just divide it by 2. Because we're not dealing with a full sphere. A full sphere would have been out here like this, and we would have had a full sphere. But we're dealing with half a sphere. Okay, so back to our calculator. Whatever our answer was then, you can either multiply it by a half or divide it. Okay, giving me 89.79. So it's to the nearest tenth would be 89.8. Remember, the cutoff is here. That causes us to round up. So 89.8. 89.8 feet cubed. Now, you're probably saying to yourself right now, can I just do this whole calculation the way it is without having to do the half? Sure, absolutely. There's our sphere. Multiplying by a half makes it a hemisphere. Let me show you how this works. Bring up your calculator. Okay, here we go. Let's clean this up. Bada boom. It's good to go. So, remember, you're dealing with a hemisphere, so it's half of a sphere. There's your half. Your original formula was 4 divided by 3, right? Pi, r, which is 3.5, cubed. Don't forget the cube. There it is. It gives you the same answer. So you can either take the half in later or put the half in initially. It doesn't matter. It still gives you the same answer.